and welcome to ITLS Academy Empower the Youth. So today in this lecture we will going to study about our next topic, that is flame atomic absorption spectrometry. So in the previous lecture we have discussed about different types of spectrometry. For example, we have discussed about atomic absorption spectrometry. We have discussed about X-ray fluorescence spectrometry. So today we will going to discuss about the flame atomic absorption spectrometry. So what do you understand by this flame atomic absorption spectrometry, or I can say that which type of spectrometry analytical technique is flame atomic absorption spectrometry is. So the simple definition is the flame atomic absorption. It is a very common technique, whenever you want to detect a metal that is present in a sample. Okay, so whenever you want to detect any metal, especially I'm talking about the metals, and you want to detect it from in the sample, so the technique that is most commonly used is the flame atomic absorption spectrometry. तो यहीं पर एक क्वेश्चन बन जाता है कि मेटल जो हमारे सैम्पल्स में होते हैं उसको कौन से एनालिटिकल टेक्निक is used to detect those metals. So the answer for this is flame atomic absorption spectrometry. So the technique is based on the principle that the ground state metal absorb the light at the specific wavelength. So the metal ions in the solutions, they are converted to the atomic state by the means of the flame. So the simple principle to understand this is, I'm just marking it. So the basic or the simple principle behind this technique is the ground state metal. Okay, the metal that are present in the ground state. So what they does, they absorb the light, and the light should be of a specific wavelength. Okay, so after that the metal ions that which are present in the solution, so what they do, they convert it into the atomic state. And how they are converted to the atomic state? By the means of the flame. Okay, so when the light of the correct wavelength is supplied, or you can say when a light of the specific wavelength it is supplied to a sample, so the amount of light it is observed is measured, and a reading for the concentration can be obtained. So okay, so here one thing is to be understood, that the sample means, you can say the sample, or you can say the atom that is present in the sample, they absorb the light. Okay, after absorbing the light of the specific wavelength, the atom becomes very excited, and it goes to the excited state. But since the excited state is unstable, so they come back to their ground state, and after coming back to the ground state, they emit the light. The simple phenomena behind this. Okay, so the flame atomic absorption, it is a very accurate quantitative technique. Okay, and it is also a qualitative technique. So this is again very important, that thing, that this absorption atomic absorption, it is a very accurate technique, and it calculate, or it analyze the quantitative as well as the qualitative technique. So not only paying attention to the quantity as well as the quality of the sample. So this is one of the main reason, that is the reason this type of analytical technique is being widely used. Why? The answer for this is point number 5. Why it is most widely used atomic absorption method? Because it is very accurate quantitative technique and also a good qualitative technique. So here in this slide, if you can say if you can see, there are two questions. First, what do you understand by atomic absorption spectrometry? And the second is, why, or what is the main reason why this technique is being widely used? The reason, or you can say the answer for this is point number 5. Okay, now let's move to the further and let's discuss the principle of flame atomic absorption spectrometry in detail. Okay, so in the flame atomic absorption spectrophotometry, the atomization is performed by aspirating the sample solution into the flame. So the first thing here to understand this point, that in this type of technique, the optimization is performed by aspirating the sample to the solution into a flame where the analyte atom is converted to the gaseous phase atom. So here the analyte that is present, so the analyte element, it gets converted to the gaseous phase atom. Okay, so the first step is the automation. It is performed by the aspirating the sample solution, okay, into a flame. After that, the analyte element, you can say, it is converted to the gaseous atom. Okay, so as the temperature of atomization get lower, or you can say as the atomization temperature get lower or decreases, most of the atoms remain in the ground state. Okay, temperature is not increasing. Okay, temperature of the atomization is not increasing, it is decreasing. So because of this factor, that the temperature is decreasing, most of the atoms, it remains in the ground state. Okay, which can observe the characteristic radiation from the radiation source. Okay, so that is very something that is that is a characteristics, that is one of the characteristics, since the atoms are remaining in the ground state. Clear? After that, since the atoms are present in the ground state, so they absorb the radiation. Okay, they absorb the most of the radiation, okay, that is coming from the light source or radiation source. Up here, what is the radiation source? So the radiation source is halogen cathode lamp, that is HCl. Okay, in which the cathode is made of the element that need to be determined and gives radiation characteristics of the element. Simple. Okay, so now the radiation which is observed by the atoms, atomic vapors, and its intensity get decreases, since the radiation get absorbed by the atomic vapors, so its intensity also get decreases. So the degree of absorption is something a quantitative measure of the concentration of the ground state atoms in the vapor. Okay, so one question arises, that what is the degree, or you can say what is the degree of absorption? So the degree of absorption, it is nothing but it is a quantitative measure. Okay, I'm just marking it down. So it is a quantitative measure of the concentration of ground state atom. Why? Because this ground state atom is absorbing most of the radiation. Okay, so the analysis is further done by comparing the observed observation with one obtained by a suitable standard sample of the analyte under certain experimental conditions. So what are the experimental conditions, students? So the experimentation condition is that is the calibration curve method is generally employed. So this is the basic principle behind the flame atomic absorption spectrophotometry. Okay, so now understood. So in this slide also, different types of questions can be made. The first question is, of course, they can ask you to explain the principle of flame atomic absorption spectrophotometry. So the answer for this is in this slide. So you can go through this slide, and the answer is in this slide. Okay, so again, in simple words, I am repeating the you can say principle. So the basic principle behind atomic flame atomic absorption spectrophotometry is, so So the technique of this flame atomic absorption spectrophotometry, it requires a liquid sample to be aspirated. Okay, that is the first point. And further, they are mixed with a combustible gases like such as acetylene, or you can say acetylene and nitrous oxide. Okay, so after mixing it with the combustible gases, the mixture is further ignited in the flame, whose temperature should be in the range between 2100 to 2800 degrees centigrade. Okay, the mixture, which mixture? The liquid sample that is mixed with the combustible gases. Okay, so during this combustion, atoms of the elements of interest in the samples, they are reduced to free or unexcited ground state atoms. Why? Because of the low temperature. Since because of the low temperature, most of the compounds get remains in the ground state, and and those atoms which absorb the light at the characteristic wavelength, or of the specific wavelength. Okay, and those rays of light came from which source? Halogen cathode lamp. Okay, so this is the basic principle behind this whole technique. Now comes to the instrumentation part. So the instrumentation part is quite interesting, because the most of the component we have already discussed in our previous slide. So this is again you can say revision of that thing. That is the component of flame atomic absorption spectrophotometer. So the first one is radiation source, second is atom reservoir, or you can say flame, third is your monochromator, then your detector and readout devices. So this is the whole systematic diagram to understand the various components. So there is a radiation source, there is a flame or furnace, then there is a wavelength sector, then photoelectric transducer, that is known as detector, then comes a signal or readout devices. So we will going to understand each part in detail. So we will going to start with the first one, that is the radiation source. As already told you that the radiation of this flame atomic absorption, it is a cathode, uh, it is a halogen cathode lamp, that is HCl. So this HCl is the source of, it is a source of radiation. Most of the means the radiation came from this halo cathode, cathode ray, sorry, what I'm saying, halogen cathode lamp. Okay, sorry. Okay, so we will going to start with the first one, that is the radiation source. So I've already told you that this radiation source, the basic source of radiation here is the halogen hollow cathode lamp. Okay, so this hollow cathode lamp, it consists of a cathode and a anode. Okay, so the cathode, it is made up of the element of the interest. Okay, and whereas the anode, it consists of tungsten. Okay, so the large voltage is passed across the anode and cathode, and which will cause the inert gas to ionize. Okay, so the inert gas ions, they will get accelerated into the cathode. Then therefore the sputtering of atoms from the cathode take place. So both the inert gases as well as the sputtering of cathode atoms will in turn will be excited by the collisions. Okay, now the second part is your atomic reservoir, that is known as flame. So here flame is used, or so there is how to means what are the common fuel or oxidant that is used in the flame spectroscopy spectroscopy, that comes the question. So example like natural gases like hydrogen, oxygen, acetylene, they are used. Their temperature should be very high. For example, if you take a very natural gas like so the basic temperature is sorry, not the basic, the optimum temperature is between 1700 to 1900. But if you are using hydrogen, then the hydrogen temperature is between 2000 to 2100. Same with the acetylene. Acetylene have a slightly higher acetylene if the fuel is acetylene and the oxidant is nitrous oxide. So the temperature is 26 to 28. Okay, so this is the flame. So different types of flames are used, like calcium flame is there, copper flame is there, potassium flame is there, manganese flame is there. Okay, so different types of flames are used. Now comes your monochromata. So again, monochromata, as I've told you in the previous lecture also, if you have seen that slide, that monochromata act as a very important part of this whole spectrometry. Why? Because monochromata is something that is used where different means, see, there are different types of wavelength. Okay, so monochromata, what does monochromata do? Since the name suggests mono means one, so monochromata helps to separate the wavelength, okay, of the emitted radiation. So a monochromata is further adjusted with the help of a computer software. Then comes your detector. So again, detector play a very important role in detecting the emitted radiation that is passed through the monochromata. So a good detector should be able to detect even if you have a very weak signal that is produced for better accuracy. Okay, then comes your readout devices, or you can say computer. So computer or readout devices, it is a very integral part of the flame emission spectrophotometer, or sorry, spectrometer. It helps us to draw the graph of the emission spectrum for various atoms of the sample. So it is done with the help of a suitable software. So this is about the instrumentation part. Now comes the process of atomic absorption. So what is the process of flame atomic absorption photo spectrometer? So if you talk about its working, so in the flame atomic absorption spectrometer, the sample is atomized, therefore the transiting from the ground state to the higher energy level. So in the excited state, every element poses a unique spectrum that distinguish it from the other element. Okay, so the spectra lines are very sharp, such as they are really overlapping each other. So this flame absorption spectrophotometer takes the advantage of this phenomenon. Okay, which phenomena? That the spectral lights are very sharp and they rarely overlap. Okay, so to identify and quantify these elements, of course it requires a very high temperature. So that is the written in the paragraph in short, that radiation from the specific light source, they are focused on the atomic vapors in the flame. So the radiation then enters the monochromata, which isolate the line of interest. Okay, the light is then measured with photomultiplier tube, or you can say detector. The signal is then processed and the computer system prints the output on the screen. Simple. Okay, in this one thing to be understood, that at a high temperature, since because as we have discussed the range of the temperature, that the temperatures are very high. So at that high temperature, the flame atomizes the sample, and the concentration of the element of interest, they are determined by using the spectrophotometer. Okay, as the detector to measure the absorbance of the sample at their characteristic wavelength or at their specific wavelength. Now moving further with the merits and limitation of flame atomic absorption spectrometry. So students, every technique, every, whether it's a chromatography, whether it's a spectrometry, every technique have certain types of advantages and disadvantages. So if we see at the merits of the atomic absorption spectrometry, so the equipment are very easy to use. This is a robust technique. The technique has a very small turnaround time or order of few seconds, moderate cost of analysis per sample, low detection limit. So, in simple words, it is a cost effective. Since if you are working in any lab or if you are working in any industry, the first thing that see that is in any techniques that are used, that a person is using or industry is using, they first see how fast it is working. So this technique is quite fast, that make it a unique or most used technique because it is very fast. It, so to operate its equipment, it is very easy to operate, so you don't need any external training, or you don't need any extra training for your employees, so that of course saves your time as well as your money. Similarly, the cost of the analysis per sample is very moderate. So of course, so this becomes the key factors. That is the reason it is used, widely used in different industries, and it has a very, if you see their cost, so their cost system is very low. Now comes the limitation. So the first limitation, it uses the flammable gases. That is one of the disadvantages. They are non-automated or analytical procedures. So they are not automated, they are non-automated, means manual. The requirement of furnace for the analysis of refractory elements. So again, it is one of the key disadvantages that is related to the flame atomic absorption spectrometry. Now if you see at the application part, okay, if you see the uses of the flame atomic absorption spectrometry, so it has a huge demand in every sectors. How come? So first of all, its application is the application of flame atomic absorption spectrometry is used in the analysis of trace metals in different sample. Okay, second is it has a useful in pharmaceutical industries, like pharma, in analysis of pharmaceutical products. It is used in water analysis. It has a application in clinical research, mining, food and beverage analysis. So as you can see, it has a great application in every field. So fast, in short, I'm saying fast is a promising analytical technique, analytical method that is extensively employed for quantitative determination of different elements in a wide range of samples. So the atomic absorption spectrophotometry is now routinely and widely employed technique for the trace and ultra trace analysis complex matrices. So it has a huge demands in your geological field. It has a huge demand in biological, environmental, in even if they have a good demands in the marine sediment industries also. They have a good demand in pharmaceutical, in food analysis industries. So it, because of its advantages, because of its low cost, because of its accuracy, it make this technique is widely used in different industries. So the flame atomic absorption spectrometry is a very sensitive technique for the qualitative as well as quantitative determination of more than 60 metals. So that makes it one of the greatest techniques that is used, because it has a it is a very sensitive technique, and it is widely used for the quantitative determination of more than 60 metals. Okay, so as it is used for determining the concentration of metal, it can be employed in the environmental analysis. It can be used to detect if there is a trace metal present in the food or not. So that is the reason it is used in the food industries also. So because of its unique advantages, it has a huge demand in every field. Now comes the end part of the lecture, that is the frequently asked question. So this part is very important. So the first question is, explain the origin of flame atomic absorption spectrum. What information can be obtained from the spectrum? So this part, that is the second part, it is very important. So you can uh, if you know the answer, you can leave your you can note it down somewhere. If you don't know the answer, you can leave your queries in the comment section below. In the next lecture, I'll be answering the queries. Then give the description about the commonly used flame in the flame spectrometry. Most commonly, I've told you the name, like calcium flame is there. Okay, so you must be knowing about the different types of the flame, and which type of flame is used most commonly used in the flame spectrometry. Then again, your third question is, list the main part of fast instrument and gives the function of each of them, that we have discussed about the components that are present in the instrumentation part. So you must be knowing all these questions. These are certain important questions. So again student, if you have any doubt, anything related to the lecture, so you can simply leave your queries in the comment section below. In the next lecture, I'll be answering the queries, as well as if you have any doubt or any queries related to any course you want to take admission in, so you can visit our website, that is www.itlsacademy.com. You can call on this number, that is 7080833450. So you can call on this number and get updated. At last, thank you for watching. Please do like, share and subscribe, and yes, don't forget to press the bell icon to get more updates on the lectures related to analytical techniques. And again, you can refer to the previous lectures for the better understanding. So thank you students, thank you once again.